we are asked, or you are asked, I'm just helping, to graph this system of equations. 3x minus 4y greater than or equal 12, 2x plus y less than 1. Now, if it asked for where the lines cross, the coordinate of where the lines cross, or whether they do cross or not, I would want to put this in the format of y equals mx plus b. Do I have my pen selected here? Y equals mx plus b. Because then I could compare the slopes, and if the slopes were the same, I'd know they're parallel. If they were negative reciprocals of each other, I would know that they're perpendicular. If they were not equal and the b's weren't equal, then I would know that the two lines crossed at one point. I could also find the point of intersection by setting mx plus b of each equation equal to each other. If everything was the same, then I would know that they're the same line. They have infinite points where they cross. However, this one asks, let's graph it. So I'm just going to graph it, and I'm going to do a little bit of a shortcut. 3x minus 4y is greater than or equal to 12. To graph a line, 2 points are needed. Well, I'll use the x-intercept, which is when y is 0, and the y-intercept, which is when x is 0. So here's the x-intercept. I'll just put x there for x-intercept. We're substituting, or now I'm substituting 0 in for y. I hate saying we on these. Negative 4 times 0 is 0, so it's when y is 0. So it's just going to be 3x greater than or equal to 12. X, to solve this, greater than or equal to 4. So here's my coordinate plane. One, two, three, 4. I'm trying to be somewhat accurate. And it says greater than or equal to 4. So since this is greater than or equal to, this line is going to be solid. And I'm going to be going to the right. Do I have this right? Greater than or equal to 4. Yes, greater than or equal to 4. So to the right of the line. Now I will find the y-intercept by setting y equal to x equal to 0. 3 times 0 is 0, so negative 4y is greater than or equal to 12. Y, I'm dividing both sides by negative 4, which means the sign flips. When you're doing inequalities and you divide or multiply by a negative number, flip the sign. 12 divided by negative 4 is negative 3. So negative 1, negative 2, negative 3. And it's going to be, again, a solid line because it's less than or equal to, but it's going to be down. Sorry about that. That's my text message on my phone. So I'm below the line and to the right of the line. This is where the shading is on this line. And because I don't have to find the point, I don't have to do anything more with this. I don't have to find the point where they intersect. If it looked to me, once I did this, that the lines were very close to being parallel, I'd probably want to put them in y equals mx plus b and then see if they were indeed parallel by using the slopes. But we'll see what happens. I'll do the next one in red. 2x plus y less than 1. I will find the x-intercept by setting y equal to 0. So 2x less than 1, x less than 1/2. Now this line is going to be dashed. This line is not, the line itself is not included in the solution because it's less than. It doesn't include the line. So here's 1/2. And it's going to be shaded to the left because it's less than. Then I'll do the y-intercept, which is when x is 0, y is less than 1. So here's 1. Hold on, I don't know if that is, I'm trying to be somewhat accurate here. So there's 1, and it's going to be shaded blue. And then I can connect those two lines. And now, I did that wrong because I cannot erase parts of this line. I learned that. I just did it again. This has to be a dashed line, and I keep forgetting to make it a dashed line because the line itself on this one is not included in the solution. And this is kind of tough to make it dashed. I'm not a good dashed line maker. I want to make it a straight dashed line, and I'm having some trouble doing that. So I'll do it like that. Hopefully that's pretty good. And we're below it. And so the shading goes like this. And this is the part we're concerned about inside here, where it's both solutions. So I'm going to make that hold on, I'm getting lines that I don't want. Let me redo this one. I don't know if it was showing on your screen, but on my screen, I was getting lines I didn't want. So this is where the solution actually is, inside here, including the solid line of the first equation, but not including the dashed line of the 2x plus y is less than 1. And I'll do that in blue just to make it clear. It includes this part, but does not include that part. And it's all of this stuff in between, including that part of 3x minus 4y greater than or equal to 12. You can also graph this on Desmos just to check your work, plug in both equations and check it. And that's it.